In this video, we are going to go ahead and do some questions which are expected questions from the point of view of probability. In particular, it is related to probability density function, cumulative density function, marginal density functions. Let's go ahead and take the first question. So it says, given probability density function as, what's the probability density function given to you? It is given as f of x is equal to kx square if x is between 0 and 3 and 0 otherwise. It says find one, constant k. Second, distribution function fx. Third, probability of x between 1 and 2. Pause the video, give it a try, then I will do it. So let's start it. See, the first part is asking you to find out constant k. You must know the property that for PDF function, whenever we integrate them from minus infinity to infinity, then the answer is 1. Area, the total area, the sum of the probability is 1. For our case, because it is only defined between 0 to 3, I am going to go ahead, integrate this function kx square between 0 to 3, and I'm going to say that this is equal to 1. Now, when we go ahead and integrate this function, I will get k x cubed by 3 from 0 to 3 equal to 1. This would mean k 3 cube by 3 minus 0 cube by 3 is equal to 1. This would mean k 9 minus 0 is equal to 1. So 9k is equal to 1. This implies that the value of k would be 1 by 9. So this is your first answer. Second, what is it saying? Distribution function capital Fx. Let's see that. What is Fx? Fx is nothing but you have to go ahead and integrate this function. So, because your function is defined for x between 0 to 3, you have to go ahead and integrate this function between 0 to 3. So please understand, ideally what do we do? Whenever I have to find CDF of a function, suppose this is the function. Suppose this is the curve parameter. The PDF of a function is that when x takes a certain value, what is the probability associated with it? But the the CDF of a function is from the, from minus infinity to that value, what is the total probability? So you find area under the curve. So usually to find the CDF of the function, till any value x is equal to x naught, you integrate the function from minus infinity to that f naught, f of t dt. This is what we do. But in my case, because the function is only defined between 0 to 3, I am simply going to say I will integrate the function 0 to 3 f of x dx. This is all that I can do. This is what I am going to go ahead and do. So because my function is only defined from 0 to 3, I am only going to go ahead and say that this is how my function is defined. So this is going to be from 0 to 3. The value of k is 1 by 9. And my function is kx square. So it is going to be kx square dx. So this will be x cubed by 3 into 1 by 9 from 0 to 3. So this is going to be 1 by 9, 3 cubed by 3. So this is going to be 3 to the power, which is going to be 1. This is going to be my complete area. Area under the curve is 1. So for every value between 0 to 3, if I take the complete area, see my function was only defined between 0 to 3. If I take the complete area of my function, then this area has to be equal to 1, right? Now, supposedly, I want to find the CDF for any x naught which is between 0 to 3. So this is 0, this is 3. And I ask you, okay, what is the CDF till x naught? Right? So in that case, I will integrate my function 1 by 9. That's the value of k, x square dx. It will start from 0 and it will go till x naught. So this is going to be x cubed by 3 into 1 by 9 from 0 to x naught. So this is going to be x naught cubed by 27. So for any x naught, you can put any value. So supposedly you ask me what is the CDF till x2. So I will put x naught equal to 2. If you ask me what is the CDF for x is equal to 2.5, I will give you till 2.5. So, ideally, what is the definition of the CDF or the cumulative density function? This is the probability that x is less than or equal to 2. So when I say that this is my CD, this is my probability density function, and I take x equal to 2. So CDF will be that x can take any value from 0 to 2. So I will put 2 here and I will get the answer. X can take any value from 0 to 3 is 1, because then I'm taking the entire area. That's where my function is defined and I'm taking that completely. So that is why I was getting here 1. Okay. So if I have to write any general CDF function, it is going to be x cubed by 27 when x is between 0 to 3 and whenever x is greater than 3, because x greater than 3, CDF for x greater than equal to 3 is nothing but 1 minus CDF till x equal to 3, less than equal to 3. And CDF till x less than equal to 3 is already 1. So this is simply going to be 0. Right? So the probability that x is greater than equal to 3, cumulative probability that x is greater than equal to 3 will be 1 minus the cumulative probability that x is less than equal to 3. And x is strictly greater than 3 in fact. And this is going to be 1 minus 1, which is going to be 0. So, when you don't have an equal to sign here, this is what happens. This is simply saying what is the probability x is greater than 3? It's 0. What is the cumulative that x is greater than equal to 3? This is 1. Now, why? Because this includes two things. This includes the probability that x is greater than 3 and it also includes that x is equal to 3. And when x is equal to 3, it includes all possible cases. It includes the CDF till x equal to 3, which is 1. So 0 plus 1, which is 1. So I can go ahead and say that between 0 to 3, it is x cubed by 27. Whatever value of x you will put, you will get an answer there. And at 3, it is 1. So when x is 3, it is 1. And even if x is greater than equal to 3, it remains. Right? Now, let's go ahead to the next part. What is the probability that X is between 1 and 2? Probability that X is between 1 and 2. So the probability that X is between 1 and 2 is nothing but the probability cumulative distribution of X is equal to 2 minus the cumulative of X is equal to 1. You can understand this like this. So if this is your probability density function, this is X equal to 2. So X less than or equal to 2 is this area. Either X is 2 or less than 2. X less than equal to 1 is this area. Right? So this is what I'm interested in finding, this area. So to find this, I just have to find the bigger area and subtract the smaller one, and I will get this. So this is nothing but you will put the value of X equal to 2 in the CDF that you just found out. Then you will put value X equal to 1 and subtract. So this is going to be 2 cube by 27 minus 1 cube by 27, and this is going to be 8 minus 1 by 27, which is going to be 7 by 27. So the answer is 7 by 27. Okay,